Hello everyone, we group 5 will present about ion lithium battery. So what is lithium? Lithium is known as the lightest metal that located in group 1 on the periodic table. It acts as reducing agent because it donates electron. Have you guys wondering how this battery works? Well, basically it's just about transfer of the ions from anode to cathode. What is actually happened here? First, the lithium atoms in the anode are ionized and separated from the electrons during this charge cycle. Meanwhile, in cathode, the ions combine with the electrons to electrically neutralize. The most common lithium-ion battery to be used is combination of lithium cobalt oxide that is put in the cathode and graphite that is put in the anode. The characteristics of this battery is it have high density, no memory effect, and low self-discharge. The first person who proposed this ion lithium battery is M.S. Whittingham that came from Binghamton University. The best part of this battery is lithium-ion battery also family rechargeable.
Lithium-ion batteries are defined as greener and cleaner energy storage device compared to other batteries due to the higher voltage, high energy density, low self-discharge efficiency, and less harmful to the environment. A lithium-ion battery composed of negative anode and positive cathode electrodes, a porous separator which helps in transporting lithium ions, and an electrolyte that acts as a guard which only allow lithium ions to flow through, while this directly tells us that electrons are not allowed to pass through the electrolyte. To add on, at the negative terminal, there is a boundary region that is called a copper current collector, while at the positive terminal, it is called an aluminum current collector. The nature of the electrode material has a significant impact on the energy density and performance of a lithium-ion battery.
Lithium-ion batteries power the lives of millions of people each day, from laptops and cell phones to hybrid and electric cars. This technology is gaining popularity due to its lightweight, high energy density, and due to its ability to recharge. So the question is, how does it work? A battery is made up of an anode, cathode, separator, electrolyte, and two current collectors, which is positive and negative. The anode and cathode store the lithium. The electrolyte carries positively charged lithium ions from the anode to the cathode and vice versa through the separator. The movement of lithium ions will create free electrons in the anode, which then creates a charge at the positive current collector. The electrical current then flows from the current collector through a device being powered such as cell phone and computer to the negative current collector. While the battery is discharging and providing an electric current, the anode will release lithium ions to the cathode, which will generating a flow of electrons from one side to the other side. When plugging in the device, the opposite will happen. The cathode will release lithium ions, which will be retrieved by the anode.
I will be presenting about the redox reaction of lithium-ion battery. At the cathode, reduction takes place. Reduction is the loss of oxygen in respect to oxygen transfer, or the gain of electrons in respect to electron transfer. Lithium cobalt oxide is formed when cobalt oxide reacts with lithium ions. These lithium ions migrate through the electrolyte medium to the cathode, where they are incorporated into lithium cobalt oxide through the following reaction, which reduces cobalt from a positive 4 to a positive 3 oxidation state. Next, oxidation occurs at the anode. Oxidation is the gain of oxygen in respect to oxygen transfer, or the loss of electrons in respect to electron transfer. The graphite intercalation compound LiC6 will form graphite and lithium ions. Lithium will then be oxidized from Li to Li+, which means there is a change in oxidation state from 0 to +1 in the lithium graphite anode. When the lithium-ion battery is powering a device, positively charged lithium ions will move from the negative anode to the positive cathode. They do this by moving through the electrolyte until they reach the positive electrode. There, they are deposited. The electrons, on the other hand, move from the anode to the cathode. When you charge a lithium-ion battery, the exact opposite process happens. The lithium ions will move back from the cathode to the anode, while the electrons move from the anode to the cathode.
Next is lifespan. Calendar life is used to indicate the battery's entire life cycle, including cycle life and inactive storage. A lithium-ion battery has an anticipated life of 2 to 3 years, which is 300 to 500 charge cycles. But still, most manufacturers expect this battery to last 5 years or 2000 charging cycles. A charge cycle occurs when a battery is fully charged, discharged, and fully recharged again. Many factors can affect the lithium-ion battery life cycle. The first is temperature. The rising of temperatures alters chemical reactions inside the battery, increasing storage capacity but also decreasing battery lifespan. The battery's internal resistance increases at a lower temperature, so it requires more effort to charge. And for the discharge and charge current, increasing the discharge current also increases power output, but the capacity of this battery is reduced more quickly when discharged at a high rate. Increasing a battery's available charge limits the number of times it can be charged and discharged without being damaged internally. Lastly, when charging a lithium-ion battery, the greater the SOC, the shorter the battery's life expectancy.
Lithium-ion batteries are generally safe and unlikely to fail. When the internal temperature of the cell rises due to some abnormal condition, the liquid electrolyte will dry up and there will be a short circuit between anode and cathode. And this can eventually lead to a fire or an explosion. Thus, to avoid such a situation, an insulating layer called the separator is placed within the electrodes. The separator is permeable to lithium ions because of its microporosity. However, when lithium-ion battery fails to operate safely or are damaged, there are some safety and precautions that needed to be taken into consideration. First of all, avoid dropping, crushing, puncturing the lithium-ion battery. Secondly, damage to all kinds of lithium-ion battery can occur when the temperatures are too high. Thus, lithium-ion battery should be stored well in a ventilated, dry cap between 40 to 80 Farad and away from direct sunlight, heat source, and water. Next, it should also be stacked and make it stable and won't bump. Last but not least, remove lithium-ion devices and batteries from the charger once they are fully charged.
As for the applications, many mobile gadgets including smartphones, watches, and laptops rely on a lithium-ion battery. Batteries made of lithium-ion have a higher energy density, making them ideal for usage in all electric cars. Lithium-ion batteries are also used in solar applications as it is rechargeable and easy to store solar energy. It is also more efficient and effective to connect lithium-ion batteries in parallel circuits for devices that require a high amount of power.